Hey guys, so this is the Mathematics Standard 2 2020 HSC paper, and in today's video we're going to be looking at non-right-angled trigonometry. And this is a common obstacle or challenge for many students who take Math Standard 2, so we're going to dive right in. Alright, so here's a question that you can expect to see for non-right-angled trig. Mr. Ali, Miss Brown, and a group of students were camping at the site located at P. Mr. Ali walked with some of the students on a bearing of 35 degrees for 7 kilometers to location A. Mrs. Brown, or Miss Brown, with the rest of the students, walked on a bearing of 100 degrees for 9 kilometers to location B. Okay, so the first part of this question is show that the angle APB is 65 degrees. So whenever it says show an angle, I draw the like a red line to show like what we're actually trying to find. Now, they've given you a lot of information up here, and we have to actually use some of this information. And the first thing you need to know is that when you see the word bearing, how bearings are measured is that the north is 0 degrees. And as you go from, you rotate from it's like a clock. When you rotate from right to left, backwards, that's the degrees, like that's the bearing. So for example, say this was x is 90 degrees on a bearing of 90 degrees. So this is really important because the first part of this question is simply taking the information and drawing it onto our chart here, a little diagram. So basically, when it says Mr. Ali walked with some of the students on a bearing of 35 degrees, that means that this is the starting position, this is 0 degrees, so therefore this angle right here is 35 degrees. Okay, so the next part is Mrs. Brown walks to B, and that's 100 degrees. That means that this would be 100 degrees. So now, to find out what APB is, which is what the question is, all you have to do is simply go 100 minus 35. And the answer to that is 65 degrees, obviously. So, yeah, so you can say, in this question, you could say the angle, this angle is 35 degrees, APN is 35 degrees, NPB is 100 degrees, so therefore APB has to be 100 minus 35 degrees, which equals 65 degrees. Cool. Alright, so next question. Find the distance AB. So AB is, so we have to draw a line here. So AB would be this line. So find AB. Now, in this scenario, what we actually have to do is we have to understand what formulas we have at our disposal. So what you can do, I'm going to minimize this window and open this window. So at the bottom of every paper, you're given a reference sheet. So as soon as you see trigonometry, any type of trigonometry, you should have this open, this bottom right part here. And these are all the tools in your toolbox that you might need to use to solve these questions. So if we go back to our question, we want to find AB. What we need to do is think about what information do we have at our disposal. So we have an angle and we have two sides of the triangle. We know the distance of two sides of the triangle. So looking at our formulas, we have to basically see, okay, which one matches most closely. So in this case, essentially we want to find C, because this, if say we know angle C, this would be lowercase c, and we want to find that distance. And we know what A is, because A would be 7 kilometers. We know what B is, because B would be 9 kilometers. And we know what C is, because C is 65 degrees. Right, so now all you have to do is plug this into a formula. So I'm going to open up this scientific calculator over here, and I'm going to, so remember the trick is, since this is C squared, in order to find C, we need to take the square root of both sides. So that's what I'm going to start with, is the square root, and then I'm going to say A squared, so 7 squared. I'm going to go plus 9 squared minus 2 times 7 times 9 times cosine 65 degrees. I'm going to close that. And our answer is 8.76. We'll probably go to 2 decimal places, 8.76. Since the third decimal is 0, we don't have to round up. Okay, so that's the answer. It's 8.76 meters. Okay, cool. Alright, so if we open this back up, we'll go to the third part of this question. It says, find the bearing of Mrs. Brown's group from Mr. Alley's group and give your answer correct to the nearest degree. Now, what we have to understand is, okay, so remember with bearings, remember you want to measure the bearing is from the source to the destination. So in this case of Mrs. Brown's group from Mr. Alley's group, so Mr. Alley is the source, or the original point, and then the destination is Mrs. Brown. So if we were to draw our little cross, the center point and the north up here, the center point would be Mr. Alley, and then the bearing, whatever degree it is, would be to the destination, which is Mrs. Brown. So if we go back to our diagram, what we want to know is, so Mr. Alley's here, so the angle we actually are interested in, and let's say we draw a line like this, the angle we're interested in, and I'll change the color, is this angle right here. So that's what we want to know. So we have a bunch of information here. Now, with this particular, I might get rid of the center cross because we don't really need it. So what I can do as well, I can draw a new north, basically. Like this is the new destination point. I mean, the new origin point is probably a better word for it. Now, we've got a bunch of information, and what I might do is just draw this up. So we have a bunch of information, so we know that this is 8.76. We know that this is 65 degrees. And there's a bunch of ways to solve this from here. So I'm going to show you one way to do it. So first off, we need to understand is how do we calculate this? So if we think about it, since this is a 360, technically if we knew this angle, if we knew this angle in the blue, and then we knew this angle in the purple, then calculating this angle here, which is the answer, would be easy because it'd just be 360 minus blue minus purple. So that should be our objective, and we have enough information to essentially fill in the gaps here. So what I'm going to do is, so the first part of this is, since these are both pointing straight up to north, you essentially can state that these lines are parallel. And when you have two parallel lines, that means that these two internal angles will add up to 180 degrees. And if you remember, we know that this is 35 degrees. So in order to find this, this angle, it's simply a matter of 180 minus 35, which happens to be, quick math in my head, 150, 145 degrees. Yep. So this angle would be 145. 145. Okay, so that's one part of the puzzle piece. That's one piece of the puzzle. So now we need to find this angle, the purple one. So how do we find that? And what we know is we have all this information about this triangle already, so then we can think, okay, what tools can we use to apply here? So what I'm going to do is get rid of this real quick. So we'll just have a little look at our formulas. And what we need is, if I maybe position this. So if I think about it, let's take stock of what we have. So we need an angle C. Okay, so the easiest one I can see is probably using the law of sines. So essentially, the law of sines is that if we know an angle and then we know how the units of the opposite line, then we can actually apply the law of sines to find the another angle. So basically the law of sines is A over sine A equals B over sine B. So if we look at our diagram, if we plug it in, we know that 8.76, which is, say, A, or no, P, I should say, and then the angle P is 65 degrees, and this, not 65 degrees, sine 65, and then we say equals 9, because 9's down here, and then we want the angle A, we can put sine A. Now, so all we have to do is now rearrange our equation. So what I'm going to, a few students might get a little confused about how to rearrange this equation. What we need to think about is first off, what we need to do is get rid of this denominator. So we're going to multiply both sides by sine A. So what we're going to get, I'm just going to write this out, we're going to get sine A multiplied by 8.76, divided by sine 65. I'll put that in brackets just to be sure. And then we can say equals, 9 times sine 9 times sine A divided by sine A. So when we have that, so essentially what we do is we're cancelling out the sign on the right side. So this cancels out with this, because anything divided by itself cancels out. And now we're left with this, so sine A times 8.76 over sine 65. So then what we want to do is divide each side by what's in the over here. So what I'm going to write is then sine A equals 9 over 8.76 divided by sine 65. right? And then the last thing you need to do is when you have a sine, you have to get rid of it, you have to do an inverse sine to each side. So the final result will be A equals inverse sine, big bracket, 9, and then divided by 8.76 divided by sine 65, close bracket. Okay, so we're going to go ahead and plug that into a scientific calculator. So I'm going to get rid of this side real quick so we can see what we're doing. So what we're going to do is we're going to put this in. So we're going to go to inverse sine and go 9 divided by 8.76 divided by sine. Make sure that's actually sine 65 degrees. Close that. Oh no. Close that. And then the result is 68.629. Okay, so 68.629. So that means that this angle, the purple, is 68.629. So now, unfortunately that's not the answer. The answer has to be 360 degrees minus 68.629 minus 145. So if we plug that into the calc, um, 360 minus 68.629 minus 145, the answer is 146.371 degrees. Cool. And that is our answer. So that is the bearing of Miss Brown's group from Ali, 146 degrees, 0.371. Cool. If you enjoyed this video, subscribe because I'm going to be uploading more math videos in the near future.